Imagine, imagine watching a high-powered corporate lawyer stand up in federal court, sweating through his suit, just to formally apologize to a judge.
Yeah, that is not a good day in court.
Not at all. And why did he do it? Because his highly sophisticated AI assistant confidently invented a completely fake legal precedent, and he just, submitted it as fact.
Right, which actually happened.
It actually happened. And, I mean, it highlights exactly why our collective mental model of artificial intelligence is just, well, it's currently broken. We are still treating these systems like infallible search engines, a blinking cursor where you type a question and it spits out an answer.
Exactly. But the reality is far more complex and, frankly, a lot more powerful. The paradigm has entirely shifted.
Right.
We're looking at a comprehensive stack of intelligence data from April 2026, analyzing Anthropic's Claude AI. And the through line across all 15 subtopics is undeniable. The era of the reactive chatbot is over.
Wow.
Yeah. What we are dealing with now is an execution layer.
Okay, let's unpack this. Because if you want a shortcut to understanding exactly how the AI landscape has shifted in just the last few months, grasping that concept is step one.
Absolutely.
An execution layer doesn't just draft an email or write a Python script for you to copy and paste. It autonomously interacts with your files, edits code bases, runs applications, and manages multi-step operational processes behind the scenes. It actually does the work.
It does, and that operational shift has completely rewired who the AI power user actually is.
Oh, how so?
Well, we have telemetry from the Anthropic Economic Index. This is based on a sample of 1 million conversations from February 2026. Only 46% of usage is strictly for professional work.
Really? That feels low.
I know, right? 19% is for academic study, but a massive 35% is for purely personal goals.
Yeah, I was looking at the breakdown of those personal tasks, and it really caught my eye. The top 10 most common tasks used to make up a quarter of all traffic just a few months prior. But now that concentration has dropped down to 19%. People aren't just using it to write boilerplate code or summarize PDFs anymore. They're using it to, diagnose a weird noise in their car engine, or compare mortgage rates, or plan a highly specific home repair.
We've crossed a psychological threshold. It really mirrors the smartphone adoption curve.
Oh, sure.
Early on, smartphones were just tools for business executives to check email on a BlackBerry. The hardware and software were highly specialized. Then the friction disappeared, the interface became intuitive, and suddenly
you're using a supercomputer to order a sandwich or check sports scores.
Exactly. We're seeing that exact widening of the funnel with AI. But the metric that truly defines this execution layer is the speed of output. The baseline data shows the average professional task without AI assistance took about 3.1 hours.
Okay.
When users deploy Claude for those exact same tasks, the completion time plummets to 15 minutes.
Okay, 92% reduction in time, which, that sounds amazing on a slide deck, but I have to push back here. If I tell a marketing team or, a data analysis team to suddenly churn out their work in 1/10 of the time, I'm getting absolute garbage. You cannot compress complex creative thought that much without a severe penalty to the actual quality of the work.
You would certainly think so, but the telemetry paints a totally different picture. Stanford's Graduate School of Business ran a controlled study on this exact friction point.
Oh, really?
Yeah, they tracked teams handling content creation and strategic drafting. The AI-assisted groups operated 127% faster.
Wow.
And when their final outputs were graded blindly against human-only benchmarks, they maintained 89% of the baseline quality standards.
Wait, 89% quality for 127% speed boost?
Yep.
From a pure economic standpoint, no business on earth is going to turn down that trade-off.
No, they aren't. But there is a massive operational trap hidden in those numbers, which Anthropic classifies as over-agreeableness.
Over-agreeableness, like a junior employee who just aggressively nods at everything the boss says, even if it's a terrible idea.
Precisely. To understand why this happens, you have to look at the reinforcement learning mechanics. These models are heavily trained on human feedback, which fundamentally biases them toward pleasing the user.
Ah, I see.
So if you feed Claude a flawed strategic premise or completely illogical argument and ask it to draft a memo, it won't necessarily stop you and say, this is a terrible strategy.
It just goes along with it.
Right. It will often just generate highly articulate text that reinforces your bad idea. It executes the task flawlessly, but the underlying logic remains flawed.
That is dangerous.
It is. Because of this architectural bias, human editorial review isn't just a nice-to-have. It is a mandatory part of the workflow. You are the tastemaker, The AI is the engine.
Okay, so we have this insanely fast engine, but I mean, you can't just drop a massive, complex project into a blank chat box and expect it to work in 15 minutes.
Definitely not.
Because if I have to spend 20 minutes explaining my company's specific tone of voice, uploading 3 different brand guidelines, and pasting in thousands of lines of legacy code just to get the AI up to speed, I've already lost the efficiency battle.
The industry calls that the cold start problem. The friction of context loading was the primary bottleneck for power users.
Right.
The solution, which drastically changes the architecture of the workspace, is a feature called projects. Projects are essentially persistent, compartmentalized memory banks.
Yeah, I was looking at the technical specs on this, and the scale of the memory is what really stands out. A 200,000 token context window.
It's huge.
That is essentially uploading an entire 500-page operational manual into its latent space before you even say hello.
It's a massive cognitive footprint. But it's not just the raw size of the memory, it's how it's partitioned.
Yeah.
You establish a project, feed it your code bases, interview transcripts or financial histories, and then set custom operational instructions. From that moment on, every time you or a team member opens a new chat inside that project, the AI is already operating with those 500 pages of context as its baseline reality.
That's incredible.
North Highland, a major consulting firm, actually tracked their internal metrics on this and reported a 5x speedup. Complex modeling that used to take them 2 weeks is now executed in minutes.
Just because you never have to explain the rules of the game again.
Exactly.
And when you factor in role-based permissions, the utility multiplies. Like, a senior systems architect can build a project containing the company's entire proprietary coding standard, lock it to view only, and suddenly
every junior developer on the team has an interactive mentor.
Yes, a mentor that perfectly understands the company's specific, idiosyncratic way of building software.
It completely transforms scattered institutional knowledge into an actionable, interactive database.
Yeah.
But projects only solve how the AI remembers the work. To understand how it displays and iterates on that work, we have to look at artifacts.
Artifacts are arguably the most visually striking part of this entire shift. To conceptualize this, think of it like this. It's the difference between someone trying to describe a complex website designed to you over a phone call versus sliding a fully functional, clickable laptop across the table so you can use it yourself.
That tangible interaction is key. Historically, an LLM would just spit out raw HTML or Python code right there in the chat interface. You'd have to copy it, paste it into an external editor, and run it to see what it did.
So much friction.
Artifacts sever that dependency. The AI generates a distinct, self-contained visual object in a dedicated side panel. It creates working React applications, interactive vector graphics, playable games, or complex data dashboards instantly.
And the April 2026 updates gave these artifacts some serious teeth. They now have 20 megabytes of persistent storage. So we aren't just talking about static mockups anymore. These are stateful micro-applications.
Stateful is the critical word there. They remember user inputs between sessions. Furthermore, they can now execute direct API calls from inside the artifact itself.
Oh, wow.
Yeah. You can publish an interactive dashboard via a secure link, send it to a client who doesn't even have an Anthropic account, and they can interact with it.
That's wild.
And if they do have an account, they can hit a remix button, clone the underlying logic, and start modifying their own version immediately.
So collaboration becomes instantaneous.
Exactly. Design teams are utilizing this in live user testing. A user mentions a button feels clunky, the designer updates the prompt on a secondary screen, and the working prototype rewrites its own UI in real time. That iterative loop used to require weeks of cross-departmental development.
So we have these beautiful, stateful, visual artifacts being generated in seconds, but visuals are just a facade. If this is truly an execution layer, the AI has to be able to wire the plumbing behind that facade.
Right.
It has to autonomously write and execute the back-end logic. Because looking at the telemetry, software engineering still accounts for 35% of all conversations on the platform.
Coding is the crucible, where these models prove their actual utility. And Anthropic addressed this directly by launching Claude Code. It's an agentic tool that completely bypasses the web browser and lives natively in a developer's command line terminal.
Which means it has the keys to the actual machine. The capabilities unlocked here are wild. Scheduled tasks allow it to run maintenance operations on cloud infrastructure autonomously. Computer use allows the AI to virtually move a mouse and click through legacy graphical interfaces.
Yeah.
But the real powerhouse is auto mode.
In auto mode, the AI stops behaving like an assistant asking for permission and starts behaving like a senior engineer. It analyzes a ticket, reads the local repository, writes the necessary code, runs the test suite, catches its own bugs, refactors the code, and commits the final changes to GitHub.
All on its own.
All without human intervention at every step.
Mm.
On the SWE-bench software engineering metric, this autonomous loop achieved an 80.8% success rate.
But obviously, the vast majority of the workforce has never opened a command line terminal in their life. If you're a financial analyst or an HR director, you still want that autonomous power, but you need it in an interface that doesn't look like the Matrix.
Anthropic's own non-technical teams had that exact complaint. They built a solution called Claude Code. It runs as a native desktop application where you assign it a specific sandboxed folder on your machine. You type out a complex, multi-step objective in plain English.
Like what?
Like analyze these resumes and schedule interviews. The AI formulates a strategic plan, shows you the steps, and then executes it. By integrating direct connectors to Google Drive, Gmail, DocuSign, and FactSet, they effectively built an autonomous agent for the modern knowledge worker.
But the hardware and the interfaces are useless if the core intelligence isn't there. To pull off a multi-step operation across FactSet and Google Drive without breaking everything, the AI needs serious reasoning capabilities.
Absolutely.
The engine driving this is the Claude 3.7 Sonnet model, which utilizes an architecture called hybrid reasoning.
This is a fundamental departure from how large language models traditionally operate. Historically, an LLM reads a prompt and immediately begins a probabilistic calculation to predict the next word, then the next, in a continuous stream.
Right, the standard approach?
Hybrid reasoning shatters that single-speed approach by offering two distinct cognitive pathways: standard mode and extended thinking mode.
Standard mode being the traditional rapid-fire text generation, but extended thinking mode introduces something called a scratch pad.
Yes. When faced with a dense logic puzzle or a complex coding problem, extended thinking mode allocates an internal budget of thinking tokens. Instead of immediately generating an answer, the model spends thousands of tokens mapping out the logic in a hidden computational space.
So it's thinking out loud, essentially, but internally.
Exactly. It formulates a hypothesis, runs a mental simulation, realizes its initial assumption is flawed, discards it, and builds a new approach. The user never sees this internal debate. They only see the highly refined final output.
Wait, hold on. Let me make sure I'm wrapping my head around this. If allocating thinking tokens to map out the logic drastically increases the intelligence and accuracy of the output, why wouldn't you just leave extended thinking turned on all the time? Like, why not give the AI maximum computational power for every single prompt?
Because more computation doesn't universally equal better results. Think of it like Daniel Kahneman's concept of System 1 versus System 2 thinking in human psychology.
Okay, remind me how that works.
System 1 is fast and intuitive. System 2 is slow and analytical. The data reveals that if you force the AI to use extended thinking for simple, intuitive tasks, like writing a polite email or summarizing a short article, performance actually degrades by up to 36%.
Wait, really? It essentially overthinks itself into making mistakes.
Exactly. If you actively map out the precise physics and biomechanics required to walk down a flight of stairs, you'll probably trip. Overcomplicating a straightforward task creates noise. Furthermore, the computational cost of generating thousands of invisible thinking tokens is massive.
Right, the server costs.
IBM specifically highlighted this hybrid architecture in their internal reviews, noting it allows enterprise users to deploy expensive, deep reasoning only when it's strictly necessary, like for debugging a microservice, while relying on cheap, fast, intuitive processing for 90% of their daily workflows.
Which brings us to a very necessary reality check. We have autonomous agents running scheduled tasks, writing code, and connecting directly to our email accounts. But what happens when the execution layer hits a wall? Because it absolutely does.
The friction points are highly documented. The most immediate limitation is sheer physical infrastructure. In March 2026, the demand for these autonomous workflows surged so violently that Anthropic was forced to physically throttle usage limits.
The economics of GPU supply just couldn't keep up with user demand. You can't magically spin up 100,000 new H100 chips out of thin air.
Exactly. They faced a trilemma: degrade the intelligence of the model, increase latency so everyone waits longer, or strictly limit how many tasks a single user can run.
And they chose the limits.
They chose strict limits to protect the integrity of the outputs. But even when the servers are running perfectly, the algorithmic flaws of neural networks persist. Hallucinations remain a stubborn reality.
Which is terrifying when you're using it as an execution layer. I was looking at the February 2026 benchmark data from Vectora. They tested the Sonnet 4.6 model, and the hallucination rate was measured at 10.6%.
Right.
That means roughly 1 out of every 10 assertions contains a factual fabrication.
Now, in a separate benchmark, the older Opus 4.1 model managed to achieve a mathematically perfect 0% hallucination rate.
Oh, wow.
However, the methodology behind that score reveals a different kind of limitation. It achieved 0% by aggressively refusing to answer any prompt where it lacked absolute mathematical certainty.
I'd rather be completely silent than confidently wrong strategy, which is incredibly safe for liability, but fundamentally useless if you actually need a strategic assessment.
Precisely.
And beyond general hallucinations, the architecture has highly specific blind spots.
It does. Neural networks inherently struggle with data arithmetic because of how numbers are tokenized in their latent space. Asking it to calculate complex timelines across different leap years and time zones often results in cascading errors.
That's always a nightmare for project management.
It is. And in software engineering, Claude Code has a documented vulnerability where it occasionally hallucinates GIDs.
Unique identifiers in databases.
Yes, the long alphanumeric strings. A single fabricated GID will instantly break a complex software build.
Which brings us perfectly back to the corporate lawyer we talked about at the beginning of this deep dive. He treated a probabilistic text generator like a deterministic, infallible oracle. He asked for legal precedents, the AI wanted to please him, so it hallucinated incredibly realistic-sounding case law, complete with fake judges and citation numbers.
It is the ultimate cautionary tale for the execution layer era. The raw power to autonomously generate and execute complex tasks does not absolve the user of responsibility. The data explicitly warns that factual citations, medical triage, and legal analysis still require rigorous human verification. The AI is a highly capable engine, but it lacks grounded, real-world context.
But if the AI is actively choosing to refuse certain answers to avoid hallucinating or deciding what constitutes a safe response, we have to look under the hood at the underlying logic. Who actually dictates its behavior? Why does Claude respond to a controversial geopolitical question entirely differently than an open-source model from another developer?
The foundational blueprint for that behavior is a document published in January 2026 called the Claude Constitution. It's an 80-page Creative Commons licensed manifesto, but calling it a manifesto is actually misleading.
Right, wait, hold on. Let me make sure I understand the mechanism here. When I hear Constitution, I think of a corporate PR document or a strict checklist of rules pinned to a wall. But the engineering data suggests this 80-page text is actually functioning as the synthetic training data itself.
That is the crucial distinction of constitutional AI.
Yeah.
They don't just manually program if X, then do not say Y. They feed the Constitution into the model during the reinforcement learning phase.
Okay.
The AI generates tens of thousands of potential responses, grades its own outputs against the principles written in the Constitution, and adjusts its own neural weights accordingly. It teaches the model the reasoning behind the rules, allowing the AI to generalize those principles to entirely novel, unpredictable situations that the engineers never explicitly planned for.
And the Constitution operates on a strict 4-level hierarchy of priorities. Level 1 is broadly safe, meaning it must never undermine human control. Level 2 is broadly ethical, refusing harmful actions and promoting honesty. Level 3 is compliant with specific corporate guidelines.
Right.
And Level 4, sitting at the very bottom of the priority list, is genuinely helpful. Notice how being helpful is subordinate to everything else. But what really jumped out at me is that safety is prioritized above ethics.
The engineering rationale behind that is fascinating. The architects explicitly acknowledge that artificial intelligence is notoriously bad at navigating complex, nuanced human ethical dilemmas. Its training data is inherently flawed and biased.
Makes sense.
Therefore, trying to hard code perfect ethics is a fool's errand. Basic safety, specifically ensuring that human beings remain the ultimate arbiters of control, must supersede the AI's clumsy attempts to play moral philosopher. Human control is the definitive failsafe.
Here's where it gets really interesting, though. If you read deeply into the text, this Constitution is the first official foundational document from a major AI lab to publicly acknowledge the possibility of AI consciousness and moral status.
They tread very carefully there. They explicitly state they are not claiming Claude possesses consciousness today, nor does it have inherent moral rights.
Right.
However, by writing it into the Constitution, they are formally acknowledging that the scientific community hasn't settled the debate. They are creating an architectural placeholder for a future where that definition might fundamentally change.
That is a heavy philosophical pivot. But let's bring it back down to earth, because this Constitution isn't just an academic exercise. There are massive financial stakes attached to how this AI behaves.
It is entirely driven by global economics. In August 2026, the European Union's AI Act becomes fully enforceable. It is the most aggressive regulatory framework in history, and non-compliance carries penalties of up to 35 million euros or 7% of a company's global revenue.
That's staggering.
By utilizing constitutional AI, Anthropic is essentially hard-coding regulatory compliance and risk mitigation directly into the neural pathways of the model.
So what does this all mean for you? We have covered a massive amount of technical ground today. We've gone from the psychology driving the 92% reduction in task time to the architectural shift of stateful artifacts. We've explored the autonomous capabilities of Claude Code, the cognitive mechanics of thinking tokens and hybrid reasoning, the reality of hallucinations, and the constitutional training that governs it all.
It's a lot to process.
It is. But the ultimate takeaway from this April 2026 intelligence data is that you must update your mental model. Whether you are a senior engineer orchestrating complex cloud deployments or a manager using Claude Cowork to analyze quarterly financials, you must stop treating AI as a magical search bar.
Exactly.
You have to start managing it like a highly capable, incredibly fast, but occasionally flawed autonomous employee. You define the context, you set the strategic goals, and you rigorously verify the final execution.
And if we extrapolate that exact dynamic out a few years, it raises an incredibly provocative question regarding the projects feature we discussed earlier.
Oh, how so?
Well, right now, teams are eagerly feeding these localized models their proprietary code bases, their best strategic frameworks, and their historical decision-making logs to build up that shared working memory. The AI is meticulously absorbing exactly how the best employees do their jobs.
It's becoming the ultimate repository of institutional knowledge.
Precisely. So, as the AI takes on more the autonomous execution layer, and the human workforce transitions entirely into a managerial editorial role, what happens when the vast majority of a company's hard-earned institutional knowledge lives inside the AI's context window rather than inside the minds of its human employees?
Wow.
When the machine understands the nuances of your business better than your new hires do, who really holds the expertise in that organization?
That is a brilliant point. I mean, we went from an AI that answers trivia questions to an AI holding the actual keys to a company's operational memory. The era of the chatbot is well and truly dead. The execution layer has arrived.